GRIAS Academy.
100 days, 100 themes, one goal, UPSC Prelims. Hello all, welcome back to the program Mission Surya Phase 3 of STEM Revision Program, where we are going to deal with current affairs completely regarding science and technology and environment. Okay, so let's get started our today's session. In our today's session, we are going to see few technical concepts which we have seen previously, the climate change current affairs of past 1.5 years and all, and we have seen few concepts regarding those topics also based on the Hindu article and the PIB. Now let us today see the technical concepts of those things, and we'll compile all the current affairs now till. Okay, now we'll go with two themes today. Those are, one is the clean technology. Let's get started with our first theme, that is clean technology. Okay, see, India's clean energy transition. India's clean energy transition. Basically, India is shifting from fossil fuel based energy from fossil fuel based energy to India wanted to shift to sustainable energy transmission. Energy transition. This is what India wanted to do due to the to climate change and major concerns like global concerns are there, so many geopolitical concerns are there. So reduce all these things and make the climate better enough. India wanted to move from it wanted to drastically shift from the fossil fuel production of this fuels like oil, gas and all to a sustainable transmission of energy, okay, for producing the energy. Okay, now let's look into it. Amidst global geopolitical shifts, where the developed nations like US has occasionally reverted to fossil fuels. They have occasionally reverted to fossil fuels like oil and gas. India has firmly signaled an unwavering commitment to a green and clean energy pathway, and fortified climate action. Okay, what is the policy? The policies of NDCS. NDCS is Nationally Determined Contributions. Nationally Determined Contributions governs this transition from fossil fuels to the sustainable energy transition. Okay, India has continually enhanced its targets. By processing from a 2030 goal. By 2030, India wanted to achieve a goal of 50%. But however, beforehand only it has been achieving this goal. That's why it increased the year of target to 2035 and even increased the target to 60% rather than the 50%. The new target is initially capacity from non-fossil fuel sources to legally upgraded target of 60% by 2035. Next, what is the current status? India has already surpassed its old 2030 target. It already surpassed its old 2030 target, achieving over 52.5%. How much capacity? 52.5% instead. Installed capacity from non-fossil fuel origins. Okay, as a late 2025, before 2025 only, the India has achieved it to 52.5%, okay, of non-fossil fuel sources, reached a staggering 256.9 gigawatts, meeting over 51.5% of total electricity demanded. Okay, so India has already achieved the target of 50% by 2030 before the 2025 ahead only. Okay, now moving on. That is about the India clean energy transition. Now the next concept is solar energy. We have seen about the solar energy previously, right? Where promoting rooftop solar solar systems, where the where it can generate the electricity, and can be consumed by the producer, and even the remaining current which is there, electricity which is left over, it can be sent into the grids, and they can be used whenever it is required, whenever the electricity is required. This is how one solar energy, one example has given up. Okay, now see, recent updates highlight that 8th commission of the International Solar Alliance assembly in New Delhi, and the strategic easing of solar panel. Remember this institutes? See, 8th session of the International Solar Alliance ISA assembly in New Delhi, and the strategic easing of solar panel efficiency. Norms by the Ministry of New and Renewable Energy. Norms by the Ministry of New and Renewable Energy. Now, let us look into a technical details of this solar energy. Like see, photovoltaic versus thermal. See, solar photovoltaic technology. The solar photovoltaic technology uses semiconductors. Uses what? Semiconductors. The silicon semiconductors, right? And this is the traditional method what we use, okay, to convert what? Sunlight directly into current. This converts sunlight directly into current. Okay, now this is what the photovoltaic technology of. Okay, next see, which an inverter charges to alternating current. From this current, inverter takes it and it converts into alternating current. This inverter takes up and converts into the alternating current. Alternatively, concentrated solar power employs tracking mirrors and lenses. It focuses mainly on tracking mirrors and lenses to focus sunlight to generate thermal heat. From sunlight, it can generate the thermal heat. This is how it has been. This solar power, concentrated solar power is employed. Okay, now next is distributed renewable energy. What does do? To decentralize power generation, the distribution of distributed renewable energy systems, which is meant for small scale systems near the point of consumption, such as rooftop solar and microgrids. Assembling of rooftop grids and microgrids are aggressively promoted. These are aggressively promoted, representing a paradigm shift from traditional centralized power grids. This is what the distributed renewable energy is. Okay. Next, coming to agri-photovoltaics. What are these agri-photovoltaics means? It is an innovative dual land use method. Model combining agricultural production with solar electricity generation. Agriculture production, it combines both agriculture production with solar electricity generation, right? Using what? The solar electricity generation and agriculture production using what? Using shade tolerant crops. Using the crops which are shade tolerant. Okay. And solar tracking systems, which uses maximizing land use efficiency. It maximizes the land use efficiency. Okay. This is the agri-photovoltaics. Okay. Next, coming to the policy, ALMM exemption in the sense to push rural electrification, the Ministry of Renewable Energy relaxed efficiency norms. Efficiency norms have been relaxed by the Ministry of Renewable Energy under the approved list of models and manufacturers. Okay. Off-grid applications below 200 watts. Off-grid applications of below 200 watts like solar lanterns, now requires only 18% efficiency. Okay, usually it is 19%, they have bring down the norms to 18%, encouraging MSME participation, for encouraging the MSME's participation. Okay, this is the ALMM exemption. Next, ISA interventions. The ISA launched the Sunrise Initiative. It launched the Sunrise Initiative, which is focusing on the circular economy. It is focusing on the circular economy, like see, end of life management of photovoltaics or batteries. Okay, and signed procurement MOUs, memorandums for small island developing states, for small island developing states. Okay, this is what ISA interventions have taken up by initiating the program called Sunrise Initiative. Next, let's see a few challenges and environmental impacts. While zero emissions during generation, end of life disposal of photovoltaic modules possess toxic e-waste risk. Photovoltaics means using this photons and electrons only, no? By using all this content, don't we produce some e-waste? Right? Obviously, by using any electronic this thing, we will be producing some e-waste. In the same way, though they do not produce any emissions, zero emissions are there, coming to the final disposable of this PV modules possess toxic e-waste risks. Okay. Furthermore, a crucial caveat remains, like while installed capacity of non-fossil sources is exceptionally high, the installed capacity of non-fossil sources is exceptionally high, actual renewable generation fluctuates and currently hovers around 20% due to intermittency issues. These are few challenges and environmental impacts. Next, the third concept is the wind energy. The generation of energy through wind. Okay. How is this working? We'll see. The Ministry of Renewable Energy recently overhauled its wind turbine regulatory framework. It overhauled its wind turbines regulatory framework, shifting from the revised list of models and manufacturers, to the new approved list of models and manufactured, ALMM wind. From revised list of models and manufactured, this wind turbine regulatory framework is shifted to new approved list of models and manufacturers. Coming to the technical details, wind energy harnesses atmospheric kinetic energy. It uses what? Atmospheric kinetic energy. India boasts a massive geographical potential estimate. India has a massive geographical potential estimate of about how much? 1164 gigawatts at 150 meters above ground level. How much it is being generating? 1164 gigawatts at 150 meters above the ground level. By what? By wind energy. Okay. Next, coming to the policy. Policy is ALMM wind. We have already told you a new approved list of models and manufactured. This has been come up, right? This has been moved to the approved list of models and manufactured. What it is moved? The wind turbine regulatory framework has been moved from revised list of models and manufacturers to approved list of models and manufacturers. The same way, coming to the policy. So ALMM, I can say ALMM, right? ALMM, this framework guarantees the quality and reliability of wind infrastructure. Okay, this framework guarantees the quality and reliability of wind infrastructure by mandating the domestic sourcing of core components like blades, like towers and gearboxes from approved Indian suppliers. Okay. Next, innovation exemptions. What are the innovation exemptions of this wind energy? Is to prevent stifling R&D, to prevent the stifling research and development. New models and manufacturers are exempt from these strict rules for up to 800 megawatts. Until 800 megawatts, these are exempted over a 2-year period. For how much period? For over a 2 years of period, because India is planning to move in a complete non-fossil fuel based country. I mean with zero net emissions, whatever it might be, the production of energy, might be the production of what you called this fuel, ethanol, whatever it might be, India is aiming to be in a net zero emission country. Okay, next. Coming to the environmental impact and scale, wind power currently contributes approximately 4.69% of the total India's electricity. Okay, which one contributes? In wind power currently contributes approximately 4.69% to India's total electricity generation. India ranks globally how much? India ranks 4th globally in installed wind capacity. In installed wind capacity globally, India ranks in the 4th place and is actively targeting to supply 10% of the global wind equipment demand by 2030. By 2030, how much equipment of wind demand it is being to produce? 10%. Basically, now we are up to 4.69%. Okay, now globally it is estimated to supply 10%, but in India as of now it is producing 4.69% of total Indian electricity. Okay, marking a massive leap in green manufacturing. It giving a maximum boost to the green manufacturing. Next, these are few environmental impact and scales. Now, so moving on to our next topic. Our next topic is geothermal energy. What is geothermal energy? Geothermal energy is production of energy from interior of the earth. Interior of the earth. We know, right, basically in the interior of the earth we have a lot of high temperatures, right? By using those temperatures, we have few spots where we can use those, by this heat what happens, the underground water gets heated. By the heat from the interior of the earth, what happens, this underground water gets heated up. Underground water gets heated, and this water, which after heating up, it forms steam or hot well bores. Okay, these can be created. Not we can clearly say hot springs also. Okay, these are created by the heating up of water. This is how the geothermal energy is produced. By now the steam and this what you called hot springs are produced, no? From in that area, what we do, we dig a well. We dig a well and place turbines, so that because of this steam or this hot springs, what happen, this turbines will move and produce the electricity. This is how we can use the underground heat also, I mean the heat which is coming from the interior of the earth also to produce the electricity. This is one of the source to produce electricity without emissions, like not using fossil fuels. Okay, now see, let us see the context of it. What is it? The Union Minister of Renewable Energy has officially notified that India's maiden national policy on geothermal energy, NPGE 2025, aiming to leverage Earth's subterranean heat. For grid integration by 2070. By this geothermal energy, by producing the current electricity from this source, the India wanted to wanted to make a grid integration by 2070. This is the main aim of national policy on geothermal energy, which is stated in 2025. Okay. Now, let us look into few technical details. That is, geothermal utilizes heat stored within the Earth's crust. Geothermal basically utilizes the heat which is stored in the Earth crust. See, high enthalpy resources. High enthalpy resources are like which uses more than 200 degrees Celsius, which is found near the volcanic zones and hot springs. Volcanic zones and hot springs, like we have Punga and Chumatang. These are the places in Ladakh. Okay, these are the places in Ladakh, like Punga Valley. Punga Valley is one of the most important geothermal spot in India, which is used for the generation of electricity. Whereas Chumatang in Ladakh, which is near to the west of Leh, the most approximate location is west of Leh. This is located in which is used in medicinal procedures and few therapeutics also. This location is precious. So, apart from this Punga Valley is the main hotspot of the India for production of geothermal energy. Okay, these are ideal for electricity generation. These two places are ideal for electricity generation. Now, let's see low to medium enthalpy. Low to medium enthalpy is approximately how much? 100 to 180 degrees centigrade. However, see, this high enthalpy resources are around 200 degrees centigrade approximately. Now, low to medium enthalpy are around 100 to 180 degrees centigrade. These are utilized directly via ground source heat pumps. They are directly used. There is no use of not required of drilling the well and keeping the turbines and all, but they can directly used for heating, cooling and aquaculture. Okay, next is next generation technology. Coming to the next generation technology for this thermal energy, geothermal energy, is the sector is advancing towards enhanced geothermal systems and advanced geothermal systems which can extract heat even from dry rocks or abundant oil or gas wells. From this also it can extract the heat so that the electricity can be produced. Okay, this is what the next generation technology is of. Okay, next. See, let's see the policy now. The NPGE 2025, the NPEG 2025 provides exploration leases for 3 to 5 years, exploration lease of 3 to 5 years and development lease of up to 30 years. Which is providing NPGE 2025 is providing these leases. Okay, it allows the extraction of critical minerals, mineral byproducts like what lithium, silica, cesium and all. Okay, which are subjected to MMDR Act. MMDR Act means Minerals and Mines Distribution and Regulation Act. Okay, under this act it allows the extraction of critical mineral byproducts like lithium, silica and cesium. Okay, next, what is the financial backing? The financial backing of this is included up to 100% of funding for non-profits under the RERTD scheme. RERTD means Renewable Energy Round the Clock Scheme. The main aim of the scheme is to provide electricity without any disturbances, like 24/7 the electricity has to be provided. This is the main aim of the scheme of RERTD, that is Renewable Energy Round the Clock Scheme. Basically producing this electricity 24/7 is not a small thing, but not using any fossil fuels, completely a sustainable and renewable sources only have to be used. Like example we can say daytime using solar energy and nighttime we can use wind energy. By using few sources like this, we can provide the electricity round the clock. This is the main aim of that scheme called RE-RTD scheme. Okay. Next, let us see few challenges and environmental impacts of this geothermal energy. See, geothermal energy operates with a footprint of 95% of lower emissions compared to fossil fuels. 95% of emissions are reduced by using geothermal energy. Okay. And serves as an inexhaustible base load power source. However, challenges remain in high initial exploratory costs and the geographical concentration of hotspots, because see, in the Himalayan regions, if we go and find this hotspots there, like where the places like Panga and all, Pang Valley and all, we have to develop a geothermal station there. To developing there, it is highly costable also, over cost and all. We can't go there and dig the wells and produce the electricity. We can do it, but it is highly cost oriented thing, and the geographical climate also has to be in a support for it to build this geothermal stations. Okay, like see the example, the Himalayan geothermal province. Okay. Next, these are few challenges and environmental impacts. Now, coming to the green hydrogen, we have seen this topic, right? See, the center has successfully operationalized the green hydrogen certification scheme of India. Green hydrogen certification scheme of India under the nodal authority of the Bureau of Energy Efficiency while commencing a 1 megawatt plant at Kandla Port. 1 megawatt plant at Kandla Port. This green hydrogen certification scheme of India has come up. Okay. Now, let us see the technical details of it. Hydrogen is celebrated as the ultimate fuel of the future. Basically, yes, hydrogen is used as the ultimate fuel of the future. To reduce this fossil fuel dependency, we are coming up with these technologies, because its primary combustion waste product is the pure water. Okay. Come on. Next, the color spectrum. The color spectrum is presently most hydrogen is not fully clean and is generated as a carbon intensive byproduct. It is generated as a carbon intensive byproduct of petrochemical processes. By petrochemical processes, hydrogen is now being generated as a carbon intensive byproduct. Okay. Now, green hydrogen mechanism. How this green hydrogen mechanism works is to be classified as green. When we will classify it as green? When hydrogen must be produced via electrolysis process. When the hydrogen is produced by electrolysis process, then we can say it is green. A process, what is electrolysis? Electrolysis is the process that splits water molecule into oxygen and hydrogen. Basically, this water molecule is breaked into oxygen and hydrogen. This process is called electrolysis. Okay, which is powered strictly by renewable electricity. Okay, next, let's see the policy. Policy of it is GHCI standard. DHCI standards to qualify a green production emission must strictly remain at or below 2 kg of carbon dioxide per kg of hydrogen. Per kg of hydrogen, how much? 2 kg of carbon dioxide has to be there. Next, National Green Hydrogen Mission. National Green Hydrogen Mission, when it is launched, why it is launched? It is launched to transform India into a export hub. To make India into a export hub, the mission targets the production of 5 metric million tons per annum by 2030. 5 metric million tons per annum by 2030. The key ports like Deen Dayal Port, V.O. Chidambaram Port and Paradeep have been designated as green hydrogen hubs. These three ports are the green hydrogen hubs in the India. Okay, next let's see few challenges and environmental impacts. While an unparalleled alternative clean fuel for hard to abate sectors in the sense we can see steel, heavy transports and refineries, all these need this fuel for the generation, right? In that cases production faces severe bottlenecks. In that energy, this factories it faces the severe bottlenecks problems in the production. Okay, it demands a massive upfront electricity. Where heavily engineered high pressure or cryogenic storages and consumes roughly how much? 9 liters of water to produce a single kg of hydrogen. For producing a single kg of hydrogen, how many liters of water is required? 9 liters of water is required, which is leading to the risks of water stressed regions. In water stressed regions, what they do? They don't even have water for drinking and not for utilizing even. For producing 1 kg of hydrogen only, it is using 9 liters of water. How come in this drought prone areas? Okay, this is one of the major challenges and the environmental impacts of this energy. Okay, hydrogen energy. Next, let us see the next thing is bioenergy and bio-based technologies. This is very much important. Let's see about it. These are the alternative clean fuels. We have seen a fuel named sustainable aviation fuel, right? Replacing this petrol and all for jet fuels. We are using sustainable aviation fuel has to be used in place of jet fuels. India has come up with that initiative also. We have seen it few days back about this initiative, right? Like that, it is an alternative clean fuels including various forms of bioenergy which are critical sustainable energy sources which are designed to replace conventional petrol and diesel. These are used to replace the conventional petrol and diesel by powering systems through cleaner combustion. By powering systems like cleaner combustion, these fuels play an foundational role in improving urban air quality. They are used in improving urban air quality and significantly reducing the greenhouse gas emission. Whatever we are coming up with this energy, the main goal is to remove the greenhouse gases, okay, to make our climate resilient. Now, next, coming to biofuels and sustainable aviation fuel. We have spoke about this, right? Sustainable aviation fuel. However, we'll see it now also. See, why is then this is in news? The Prime Minister recently inaugurated India's first bamboo-based bioethanol plant in Assam. First bamboo-based bioethanol plant in Assam. Okay, which simultaneously Indian Oil signed a memorandum of understanding with Air India. To what? To supply sustainable aviation fuel, highlighting in the rapid integration of biofuels into the aviation sector. Biofuels have to come up in the aviation sector. This is the major goal. Okay. Next, coming to the technical details. Generation of biofuels and properties. We'll see first this. We'll see the fundamental mechanism. Biofuels are liquid or gaseous fuels. Basically, they are liquid or gaseous. These biofuels are liquid or gaseous. Okay. These are derived from what? Organic biomasses. And many of agricultural waste and all. Okay, providing a cleaner alternative to fossil fuels. We are aiming to eliminate the fossil fuels so that no fossil fuels are there, no emissions are there, and global greenhouse gases emissions get reduced. This is our main aim. We have 4 generations of biofuels. The 4 generations are the first generation, which are produced directly from edible food grade feedstocks. Edible food grade feedstocks like wheat, corn, sugarcane, soy, etc. Okay, now coming to the second generation. Second generation, what are they utilizing as the feedstock? They are utilizing lignocellulic biomass. Okay, lignocellulosic biomass and non-edible waste. Lignocellulosic biomass and non-edible waste are used as a feedstock in second generation biofuels. Like example, wheat bran, animal fats, cooking oil, Jatropha curacas, and etc. Next, bamboo is an excellent second generation feedstock. Bamboo is an excellent second generation feedstock due to its high lignocellulose content. Basically it has a lignocellulose content. That's why bamboo is very good feedstock for second generation biofuels. Now coming to third generation biofuels. In third generation biofuels, what are used? Some bacteria like algae are used, like cyanobacteria, microalgae are used as biomass. Okay, and these are derived from microalgae and cyanobacteria biomasses. Okay, next coming to the fourth generation of biofuels, these utilizes genetically engineered microorganisms. Genetically engineered microorganisms like E. coli, which is genetically engineered E. coli, Saccharomyces cerevisiae. These are few genetically engineered organisms which are used in the fourth generation to maximize the fuel yield. For maximizing the fuel yield in the fourth generation biofuels, these bacteria are subjected, they are biotechnologically changed, like by giving them the production capacity, by introducing the gene which is responsible for fermentation process and all. This is used. Okay, next, moving on. Let's see the ethanol characteristics. Basically we have seen, right, we are using 20% of ethanol, blending ethanol into our petrol. We are coming up with, right? We call it as E20 fuel, isn't it so? The same thing we'll see now. Ethanol is a renewable anhydrous ethyl alcohol. Renewable anhydrous ethyl alcohol, while it boasts a high octane rating. It boasts a high octane rating for better engine performance. For better engine performance, it is roughly 27% less energy dense than the standard petrol. Okay, now coming to the sustainable aviation fuel. The sustainable aviation fuel, how it is produced? It is produced from non-petroleum feedstocks. Non-petroleum feedstocks like agricultural residues, algae and wastewater sludges. Okay, these sustainable aviation fuels can be blended up to 50% with conventional aviation turbine fuel. With the conventional, the jet fuel we usually say, with this jet fuel it can be blended up to 50%. 50% can be blended. Okay, what the sustainable aviation fuel can, 50% of sustainable aviation fuel can be blended with the normal jet fuel which we are using now in the aircraft and all. Okay, this is one of the major change we are going to bring up. Next, policy framework, EBP program and initiatives. EBP is ethanol blending program, ethanol blending petrol program, which is launched in which year? 2003. This EBP program promotes what? Mixing ethanol with petrol. Mixing the ethanol with petrol to lower carbon emissions. To control what? To control the carbon emissions, we are blending this ethanol with the normal petrol what we are using in our vehicles. See, example, E20 fuel cuts emissions by approximately how much percentage? 30% compared to E10. Not 10%, utilizing 20% of ethanol in the petrol mixing. What happened? It reduced the emission up to 30%. See, the national policy on biofuels, 2018 was amended to advance the 20% blending target. To advance the 20% blending target E20 to 2025-2026. 2025 to 2026, up from the original 2030 deadline. Generally the deadline is 2030, but as it is India is achieving it faster and it is making it possible, the target has been reduced to 2025 and 26. Now, the another scheme from the government of India is PM Jeevan Yojana. This specifically targets the financial supports and establishment of second generation ethanol projects. Second generation ethanol projects. Next is the sustainable aviation fuel mandate. India has officially mandated a 1% of SAF, 1% of sustainable aviation fuel blending requirement for jet fuel which is sold to international airlines effective from 2027. From 2027, 1% of SAF blending has to be there when we sell this jet fuel to the international airlines from 2027. Okay, this has to come up. This is from the Mission SAF mandate. Okay, next concept is biogas and compressed biogas. See, India's first cooperative multi-field compressed biogas plant was recently inaugurated in Maharashtra. Where? In Maharashtra. It is developed by the assistance of National Cooperative Development Corporation. National Cooperative Development Corporation to process jaggery and molasses. To process the jaggery and molasses. The Ministry of New and Renewable Energy has also updated guidelines for the National Bioenergy Program. They have updated this Ministry of New and Renewable Energy updated guidelines for National Bioenergy Program. Let's see a few technical details of it. The technical details enhances that anaerobic digestion and fuel mechanisms. In that we'll see raw biogas generation. How this raw biogas generation is begun? Biogas and biomethane. The biogas and biomethane are generated by anaerobic digestion. Anaerobic digestion means oxygen free breakdown, without oxygen. Oxygen free breakdown of organic waste including cattle dung and agriculture residue. Okay. Next, what is the chemical composition of it? Chemical composition is raw biogas primarily consists of methane. What it contains? Methane of what percentage? 55 to 60% and carbon dioxide of 35 to 40% alongside trace impurities like hydrogen sulfide and water vapor is also present in the raw biogas. Next, what is the conversion to what is this how this raw biogas is converted to the compressed biogas? We'll see. To produce compressed biogas which functions similarly to the CNG, what we are using, the CNG vehicles are there, no, which similarly this compressed biogas acts as similarly as the CNG. Okay, which is the raw biogas is purified to raw biogas. What we have said, we have this which has the methane and carbon dioxide and few impurities of hydrogen sulfide and water vapor also. This raw biogas is purified to remove impurities, elevating the methane concentration to over 90%. It is then highly compressed to 200 to 250 bar pressure. From this, the compressed biogas is produced from the raw biogas. Okay. Next, coming to the policy framework, NBP, SATAT and Gobardhan. These are the few initiatives. These are the few policy frameworks. We'll see. National Bioenergy Program, NBP. This is a major initiative to utilize what? Surplus rural biomass. To utilize the surplus rural biomass. Its components include the waste to energy program. From waste to energy program, from where what you call indoor ranked first, right? And using pyrolysis, gasification and urban waste, and the biomass program which supporting pellet manufacturing without requiring complex clearance documents. This is the scheme of National Bioenergy Program. Next comes the STAT initiative. STAT initiative is Sustainable Alternative Towards Affordable Transportation. Sustainable Alternative Towards Affordable Transportation, which focuses on what? It focuses on establishing a robust ecosystem and plant infrastructure CBG production, in the sense compressed biogas production and automotive uses. Okay, next is Govardhan scheme, which aims, what does Govardhan scheme aims? It aims to convert the rural cattle dung and solid farm waste into valuable bio-CNG and agricultural compost. Okay, these are few policy and frameworks of this. Next, coming to our next topic is biobitumen. What is this biobitumen now? Biobitumen is nothing but which is used in the roadway constructions. Like how it is a binding agent, used as a binding agent. Generally we use, right, like we mix sand, this gravels and this crushed stones, and we'll add some bitumen to it, a binding agent, and we'll mix it and we will spread on the road. We call it as thar, right? That we are replacing it with biobitumen. Okay, why it is in use is, India has recently become the first country globally to successfully commercialize the production of biobitumen. First country to to successfully commercialize the production of biobitumen for roadway construction. This breakthrough was developed by the CSIR, Central Road Research Institute, and CSIR, Indian Institute of Petroleum. Okay, next, coming to few technical details of it, we will see thermochemical conversion and pathways. See, coming to the material science, to the background of it, biobitumen is a renewable bio-based binder which is designed as a green replacement or modifier for conventional fossil fuel derived petroleum bitumen used in flexible asphalt pavements. Asphalt pavements is nothing but we use the same which I told you, the sand, the gravels and the crushed stones which we take, and we mix them with the bitumen. Okay, this is the asphalt pavements. Next, production process. Coming to the production process, unlike traditional bitumen, it is synthesized from the organic agricultural waste, specifically crops like rice straw, through highly controlled thermochemical conversion processes. Next, moving forward, let's see the 4-step technology at pathway, like feedstock collection. How these densifying post-harvest biomass, whatever it is left over, the biomass after the post-harvesting, these are biomass into pellets. They are converted into pellets. Next, pyrolysis is happening by how limited oxygen is subjected to thermal decomposition. Producing bio-oil. This is the primary precursor. Okay, next, synthetic gas and high grade carbon are produced in the pyrolysis process. Next, upgradation. How? Chemical rheological operations to improve the viscosity and addition of the bio-oil to the match VG grade bitumen. Okay, next, applications, blending with conventional bitumen, that is 20 to 30% of replacement for road laying. This is the application, like it has to be blended with the conventional bitumen for road laying. How much? 20 to 30% of the replacing. Next, coming to the environmental impact and utility of this biobitumen, tackling air pollution by giving economic value to the rice straw. Biobitumen directly curbs the practice of stubble burning. A major source of particulate air pollution in northern India. It is the particulate air pollution in the northern India. Next, coming to the compatibility, it is fully compatible with existing hot mix ash plant asphalt plants and standard construction practices, ensuring zero compromise on road performance. Zero compromise on road performance while creating multiple value streams like biopesticides and batteries. These are few environmental impacts and utilities of biovitamins. Okay, now the next topic is bio-based chemicals and enzymes. Why it is in news? Because to modernize its industrial landscape, India has heavily prioritized the development of bio-based chemicals and enzymes under the Department of Biotechnology. Biotechnology's newly launched Bio-E3 policy. Okay, now let us see into the few technical details. Fermentation versus fossil fuels. Everyone must be knowing fermentation process, right? From our childhood we are seeing. Okay, now let us see the production mechanism. These bio-based chemicals are industrial grade substances. These are the industrial grade substances which are manufactured from renewable biological resources such as like corn, sugarcane or agricultural residues. Okay, unlike traditional petrochemical methods like using coal, oil, gas and all, these methods rely on fossil fuels. Unlike the traditional petrochemical methods that rely on fossil fuels, these are created through biological processes. These are created through the biological process, like how? By using fermentation process or enzymatic reactions. Okay, next, what is the role of enzymes in this what is the role of the enzymes? The enzymes is biological catalyst. Biological catalyst is the enzymes which are crucial in this sector, Bio-E3 sector. They accelerate what? Chemical reactions during production and operate efficiently at lower temperatures. They operate efficiently at lower temperatures and pressures, drastically reducing energy consumption. They basically reduces the energy consumption and making manufacturing highly sustainable, and making manufacturing easily and highly sustainable by reducing the emissions also from the industries. Okay, this is how enzymes are used. Next, coming to the economic significance and structural challenges, important substitutions, like developing this sector is a strategic necessity. Developing this sector is strategic necessity for India to reduce its massive reliance on foreign petrochemicals. For dependency on foreign petrochemicals, example like India imported approximately how much? $480 million worth of acetic acid alone in 2023. In 2023, if acetic acid is alone been imported, around $480 million of acetic acid is alone imported in 2023. Now, what is this application? These chemicals are extensively utilized across the plastics, cosmetics and pharmaceutical industries. Okay, in all these industries, these chemicals and enzymatic reactions and fermentation process are mostly suitable rather than using the petrochemical things. Okay. Next, coming to the industry risks. Despite its potential, the sector faces few hurdles also. Like what? Bio-based products currently suffer from high initial production costs compared to cheap petrochemical alternatives. Compared to these petrochemical alternatives now which are available, these bio-based products currently have higher cost issues. Okay. Furthermore, uncertain biomass supply chains and industrial reluctance to abundant establishment of petrochemical system slow down widespread adoption. Okay. So these are the topics for today. I hope you all like these topics, and if you want a detailed note on this lecture, do visit our website and download it from there. The links are provided in the description below, and do follow our Telegram channel and Instagram channel, and do like, share and subscribe our YouTube channel for your UPSC preparation. I'll see you all tomorrow with another content. Thank you.